Students, hope you and your family members are safe and in good health. In this video, I am going to discuss about analysis of variance. It is in Unit 4.3 of Core Course 10 Introductory Econometrics. We know that TSS equals to ESS plus RSS. I am explaining these three terms later. The tabular representation of these values along with their corresponding degrees of freedom is known as ANOVA table. Consider this two variable regression model with the intercept present. So our estimated model is this. Now take the term TSS, total sum of squares, first. It is given by this formula, and the degrees of freedom is n minus 1. Here we have n number of observations and we lose 1 degree of freedom in computing the mean y bar. The two components of TSS are ESS, explained sum of squares, and RSS, residual sum of squares. However, in some books these two components are referred to as RSS, regression sum of squares, and ESS, error sum of squares. So don't get confused and be careful about which version you are using. In this video, I am taking ESS as explained sum of squares and RSS as residual sum of squares. This is the formula of ESS where xi square is known and the only unknown is beta 2 hat. So degrees of freedom is 1. The general rule for computing the degrees of freedom of ESS is the number of coefficients to be estimated minus 1. Here we have considered the two variable regression model. So the degrees of freedom of ESS is 2 minus 1, that is 1. In a k variable regression model, the degrees of freedom of ESS will be k minus 1. The other component of TSS is RSS, residual sum of squares, which is computed with this formula, and the degrees of freedom is n minus 2. For a regression model with k parameters to be estimated, the degrees of freedom of RSS will be n minus k. As we are using estimated value of y, that is y hat, we lose degrees of freedom equivalent to the number of coefficients to be estimated. The format of ANOVA table is given here. In the first column, we have the values of sum of squares and the corresponding degrees of freedom are here. In the last column, we have mean sum of squares. By dividing sum of squares with their respective degrees of freedom, we obtain MSS. Now, the question may arise, what is the use of this ANOVA table? See, under the null hypothesis, beta 2 equals to 0, and with the assumption that the random error terms ui's are normally distributed, the test statistic z1 square follows chi-square distribution with 1 degree of freedom and z2 follows chi-square distribution with n minus 2 degrees of freedom. The ratio of these two statistics divided by their respective degrees of freedom, we call it f, follows f distribution with 1 comma n minus 2 degrees of freedom. Now you can check from the ANOVA table that this f statistic is nothing but the ratio of these two values, that is MSS of ESS divided by the MSS of RSS. Now this F ratio provides a test statistic to test the null hypothesis beta 2 equals to 0. We compute the F ratio from ANOVA table, and as this ratio follows F distribution, we compare the computed value with the critical F value obtained from the F tables at the chosen level of significance and given degrees of freedom. If the computed value is higher than the tabulated value, we reject the null hypothesis beta 2 equals to 0, and it is said to be statistically significant at the chosen level of significance. In a k-variable regression model with f-test, we can check the joint significance of all the coefficients except the intercept. In that case, the null hypothesis is beta 2 equals to beta 3 equals to dot 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 beta k equals to 0. Thus, f-test is a measure of the overall significance of the estimated regression. Also, there is a relationship between r square, that is goodness of fit, and the f ratio. As r square equals to ESS by TSS, so 1 minus r square equals to RSS by TSS. and using this we can write f equals to r square by 1 divided by 1 minus r square by n minus 2. Therefore, f and r square vary directly. Higher is the value of r square, higher will be the value of f, and it becomes statistically significant so that we can reject the null hypothesis beta 2 equals to 0. When r square equals to 1, f becomes infinite, and when r square equals to 0, f is also 0. So f test is also a test of significance of r square. With the f test, we can test the null hypothesis that r square is 0. That is, the present model is not a good fit at all. So this is the significance of ANOVA table. Also, I want to add, just for your knowledge, that regression model with only qualitative variable, that is dummy variable, as independent variable is known as ANOVA model, and regression model with both qualitative as well as quantitative variables as independent variables is known as ANCOVA, that is analysis of covariance model. So this is all about ANOVA. For any query you can always contact me. Thank you.